So this is my most recent personal project. It is the scoreboard to my bubble hockey table. And it does everything that you want a scoreboard to do: track goals, control the lights, play sounds, have the LEDs indicate the score. And I want to describe it. So first, it is powered by a 5-volt DC barrel jack. Originally I had plans to make it battery powered, but since adding the LEDs, they draw a lot of current, and I did not want to have to keep on replacing batteries, because that'll be another cost sink. And the next thing I want to talk about is the case. So the case has a bunch of different things. So in the back has little cutouts for the air holes for the speaker. It also has these little side pockets here. So I'm using a Raspberry Pi Pico 2. And so this little slot allows me to plug in my mini USB really easily. As well as the other side, I'm using a DF Player Mini to play the songs, which is basically a built-in MP3 player and amp at the same time. And this takes in a mini SD card. And so I can easily just grab it. So I don't actually have to take apart the case to mess with the code, which is really, really helpful. Furthermore, if I did need to remove the case, I've made sure that all the connections to the actual bubble hockey table are disconnectable. So these two go to the goals sensors on each side, and these control the LEDs. And so all I need to do is take off these 2 bolts, and then I can remove the entire thing, work on it, etc. Like I said, inside I'm running this on a Raspberry Pi Pico on Thonny, so using MicroPython. And I'll post the code on the GitHub so you can see exactly how it runs. But as you see from the front, there are 5 inputs, and obviously there's no labels yet. Only I can control this scoreboard. But from left to right, it'll go the lights. So this will just give power to the lights or not. You have the on-off button, volume control, select button, and start button. So if I wanted lights on, all I have to do is start it on. And you can see these little indicators over here. And also, you can see you have live volume control on this one, and the lights turn on. And there's little LED indicators on this side. It's not very good with the video, but I'll have little bars describing exactly what it is, but for now it's just the audio. You'll see game to 3,
game to 5,
game to 5,
game to 7,
game to 7,
3 minutes,
and then timed, so 3 minutes, 5 minutes, 7 minutes,
5 minutes, 7 minutes, replay,
cool.
Game to 3.
So now that you have everything on and you'd like to see the function, this is a game to 3. Like I said before, it'll count the timer, time elapsed in this middle column. And so if you were to be playing the game and you go ahead and score, plays a buzzer sound effect, it adds a tally to my score, and it turns the LEDs red, and then it'll return back to game time until you win. So if you wanted to see what happens when you win in a game to score, so if this black team wins by scoring another goal, it'll play a different soundtrack. It's quite long and frankly bad manners because it's pretty funny. But if you wanted to skip, you just go ahead and click the start.
Wins.
It'll tell you who wins,
Game to
and then
3.
you restart. And then you can choose
Game to 5, game to 7, 3
a
minutes.
timer game, which will do basically the same thing, except it'll have a countdown timer, and at the end, it'll have a buzz sound effect, verify who wins, and then play the corresponding audio. And so at the end of a timer game, the time will elapse.
Tie.
Blow the whistle, determine the score. In this case, it was a tie. And then you can go ahead
3
and
minutes.
restart the game.
5 minutes, 7 minutes, replay.
Some of the big challenges with this scoreboard was thinking a lot more mechanically. So I had a revision 1, which I'll also have on my GitHub, where it's just kind of the ideas of a scoreboard. Everything's on a PCB. However, it is just a PCB. It's not really mountable. It's not really able to be put onto a board. However, this takes the physical constraints a lot more into perspective. For example, how exactly are you going to mount it? What size is your PCB going to be? How are you going to display? So you see I have like a red like acrylic on the front. So how are you going to basically hide the PCB to make it look like a nice scoreboard? How are you going to interface the buttons on the case of the board, not necessarily on the PCB? So each one of these is a breakout board, a daughter board, if you will, which each have their individual screw holes, which you'll see in the 3D print model online, as well as for prototyping. I want to still be able to have access to quick debugging if everything is complete and built. If I need to take it apart, how am I going to have the connections? I need them to be simple, but I don't want them to fall out like Duplont's connectors. And then lastly, powering it. Originally, I wanted it to be battery powered, but in the end, I found that just not having to include a power regulating circuit it saves you a lot of room and b a lot of headache. Having just this 5-volt, 5-amp barrel jack solves all of my problem needs, and especially since I added the lights to keep the dome lit. Those draw, I believe I have 30 LEDs, which can each draw up to 60 milliamps at full brightness. So I have an extra 1.8 amp current draw, which is definitely very high for battery powered applications. So in the end, I decided to go with the barrel jack. It kept my design much simpler.